We're here at Cambridge University, the engineering department. This is actually the Institute for Manufacturing. And we're currently in the DAL automation lab. It's a laboratory environment that's used as a test bed for the research group looking into building manufacturing systems and control systems and understanding how those systems will be more resilient to disturbances and change. We have a slightly unusual use of a vacuum forming machine. Our research work is really understanding how do we build manufacturing systems that are much more resilient to problems. Problems can be things like variation in product quality, product dimensions. So the way in which products come together, assemble, when you have these problems, how do you handle them better? So for one of our key research projects, we're looking at how we can build resilient manufacturing systems. How we can handle disruptions, and that can be to do with part quality or part shortages in the production process. So for us to do this work, it was very key that we had a way of manufacturing parts where we could have different dimensions in the parts. And we saw that vacuum forming would be a key technology for allowing us to do that. By varying process parameters in vacuum forming of parts, we could vary the dimensional tolerance of a part. And that's the work that we've been doing with Formech. So in this work, it's an upper cover that goes onto a gearbox. You can see we formed this lid, and you can see that there's some standoffs in the lid here that fit into the assembly. By varying process parameters, we can vary the size of these standoffs, affecting the quality of the assembly. This is the piece that goes into the assembly process. You can see we've machined the edges to leave the final component. Again, you can see the standoffs for the part, and you can see that we're adding an ID onto the component so we can track it through the manufacturing process. So the Formech machine that we chose was the HD686. This was a good level of vacuum forming machine as it provided us with some automation on board the machine for actually capturing process parameters required in forming the parts, as well as for clamping the parts, controlling the heaters effectively. So another capability on the Formech machine that was really key to us was being able to integrate the machine into the rest of the production system. The Formech machine comes with a Modbus interface that effectively allows us to interface the Formech machine back into our control system, allowing us to integrate the operations of robots such as this Fanuc M16 to come and do the material handling process of both loading material from a conveying system into the machine, forming the parts, unloading the part from the Formech machine back onto the conveyor system to go off into the rest of the production process. We were very pleased to use Formech for doing this work. Key in the early stages of this work was actually understanding what was going to be a key technology for us being able to form plastic parts. Since then, we've been using the equipment well, and again we've been using technical assistance from people in Formech to develop the interfaces to allow to integrate it into our production control system and move forward. So we've been very happy working with Formech on this work. As part of the manufacturing engineering course here at Cambridge, we like to introduce our students to new rapid prototyping technologies, everything through from 3D printers, laser cutters. One of the new technologies we've also added is vacuum forming. So in this work here you can see the students are using a 508DT Formech vac former for producing some plastic parts. This actually forms a blister pack to go around a little project that the students build in getting used to using workshop equipment. The student project is to build a small perpetual pendulum, basically, so they're learning some machining skills, some tube bending skills and some turning skills, and of course some electronics inside it, and they build the whole product. To finish the product off, we like to get them involved in some packaging, and that's where we're using the vacuum form technology. So for this, you can see that they're actually producing a mould, and then we're forming, so effectively forming this out of PET G, about 1 millimetre thick. And this basically forms a blister pack that they can use for holding their product if they were going to package it and sell it. It's a very manual process that the students can get involved with in forming plastic parts. Again, a single 13 amp socket and no air supply required, so it's very easy to install, whereas the machine next door in the automation lab, the 686, a much more advanced machine that we can integrate into automated processes, repeatable part production on that type of machine.